What's up, Logic fans? Welcome to our second video on section 5.6. So this is video 5.6b. Let's pick up right where we left off and let's jump into example 2 here. Can you expand this existentially quantified sentence on a with one object, with two objects, and with three objects? Okay, you've had some time to think about this. So what you're going to do here is there has to be at least one thing that lacks the property f. So if there's only one object, that means it's going to be A, right? Now if there's two objects and at least one thing lacks the property f, it's going to be not FA or not FB, okay? And that's exactly what this ends up looking like, right? So at least one thing lacks f, so either A lacks it or B lacks it, possibly both. Okay, and then similarly, if you have A, B, and C, it's going to be FA or not FB or not FC, right? And that's pretty straightforward, but it's interesting because if you'll notice this, it has something in common with one of the universally quantified sentences. Which one? It's a little bit hidden, right? But it's this one. Okay, right? So you have to picture it with the De Morgans. So obviously they have not FA and not FA in common, but then you've got not FA or not FB by De Morgans. Okay, and same thing for here. So this one is in fact logically equivalent to it's not the case that for all x, fx. Okay, and just think about them in ordinary English. At least one thing lacks f. It's not the case that everything is f. Right? So those are logically equivalent, and this is sort of some evidence of that they have the same expansion. Okay, moving on to number 3, it's not the case that something is f, right? In other words, nothing is f. So not FA, right? And another way of thinking about it, of course, is that 3 here is the negation of 1. So if we take 1 and we just negate it, right, you're going to end up with an expression like this, and that's exactly what it is, right? Nothing is f, so it's not the case that either A or B is f, right? And similarly here, you're going to end up with an expression that's just the negation of it's going to be the it's going to be the negation of, so we're looking at 3 here as the negation of 1. So it's just going to be the negation of what you had in 1 for 3 objects, right? And it's going to look like that. Now, after you De Morgan this through, you get not FA and not FB. So this is saying nothing is f, so A is not f and B is not f, right? Similarly here, A is not f and B is not f and C is not f, right? So does this one remind you of any of the universally quantified sentences? And again, with De Morgans, you see that it should remind you of this one, right? And so we see once again powerful evidence, right, that it's not the case that something is f is logically equivalent to it's the case that everything is not f, right? Which again was this one right here. Okay, so interesting stuff. All right, can you go ahead and finish this off? How would you translate number 4? Well, 4 is just the negation of what we have in 2. So it's going to be 2, right? And it's going to be the negation of each of those. So after you double negate this, it's going to look like this. Here you're going to have it's not the case that this whole thing. And here you're going to have it's not the case that this whole thing, okay? And if you imagine that, sort of cleaned up with De Morgans and then the double negations all done, what you're going to end up with is FA and FB. Like this. And this one's going to De Morgans and double negate to FA and FB and FC. Right? Like that. And once again, which one of these, this is the existentially quantified one here, which one of the universally quantified ones that we did does that remind you of? Pause now. Well, it looks just like the first one, right? So again, this one is going to be logically equivalent to this guy here. And again, that makes intuitive sense. Everything is f. It's not the case that a single thing lacks f, right? Those are logically equivalent expressions. So that's the basics of expansions. What I want to do now is I want to look at some more sophisticated expressions and how to expand them. So for practice, let's take a look at how the categorical sentences work, A, E, I, and O, okay? And could you expand, let's start with the categorical A on with one object, with two objects, and with three objects. What would this sentence come to in its expanded form? Pause now. Okay, so what you're going to do if you have only one object, right, is it's going to say everything is such that if it's F, then it's G, right? So provided that everything is, if it's F, then it's G, and you've just got the one object A, that means that A is going to have to be such that if it's F, then it's G, okay? Now, same sentence, okay, if you had two objects, right, it would have to be the case that since everything is such that if it's F, then it's G, then you would have to have a situation that looked like this, right? You would have to have it for the object A, and you would have to have it for the object B. So B is going to be that way, and A is going to be that way. Okay, so everything satisfies this description. Two objects, that means A satisfies this description, and B satisfies this description. And of course, if you have three objects, right, it's just going to be that way for the case of C as well, right? So it's going to end up looking just like this. Okay? All right, looks pretty good. Let's go ahead and try to expand with one object, two objects, and three objects the categorical E statement. For all x, if x is F, then x is not G. Okay? Pause now and give that a try. Okay, so this case is pretty straightforward, right? So it's just going to be like these, except you're going to have the not G, right? Everything satisfies that description. Here's the description, right? Looks just like that. And so that's going to be exactly what it looks like. Okay, what about the categorical I statement? Expand with one object, two objects, and three objects. What does it look like? Pause now. Okay, so we've got one thing, right? One object. Something is both F and G. So A is going to have to be both F and G, right? Just like that. Okay, now if you've got two things, it's going to be A is like that or B is like that, right? So it's going to look just like this. It's going to say at least one thing is both F and G. So either A is both F and G or B is both F and G. So that's exactly what it's going to look like. And of course, if you had a third thing, and you should be, I'm trying to do this in a way so that you can extrapolate the pattern, right? It's going to look just like this, right? Where you have it for the object C too. So at least one thing is both F and G. So if you have three objects, either A is both F and G, or B is both F and G, or C is both F and G, right? And that's exactly what it's going to look like. Pause now and try the categorical O statement. Okay, this case is pretty straightforward, right? It's just going to look like this. Okay, and that's what this sentence means. Expand, at least one thing satisfies this description. So if there's one object, A satisfies it. If there's two objects, either A satisfies it or B satisfies it. If there's three, then either A satisfies it or B satisfies it or C satisfies it, right? Pretty straightforward stuff. And again, let me emphasize, and we'll do an example about this later, but like if this were featuring as a premise in an argument, okay, and you were trying to make demonstrate that that argument was invalid, you might be sort of having a hard time figuring out what to do, in the sense that, you might be working on an interpretation like this, for example, Okay, and you might be wondering, do I need to put a plus here, a minus here in order to demonstrate this argument to be invalid? And I'm not really sure what to do here. Well, if you've got it expanded with 3 objects, you can just look at this sentence and you can say, okay, if that's the conclusion that I need to make false, then every single one of these disjuncts needs to be false. Okay, and that can tell you how to fill it in. Contrastively, if this is featuring as a premise and you need it to be true, you need at least one of the disjuncts to be true. So in that case, maybe you would go like, like this, and that tells you how to make this sentence true, and it doesn't have the existential quantifier. And so that's one of the really nice uses of being able to expand sentences, is for their facility in helping you offer interpretations. Okay, and we will do an example of that towards the end of these lessons with 5.6, where you actually have to demonstrate invalidity using expansions. Okay, let's try a slightly different type of sentence and how to expand it. And again, relations and identity are covered in subsequent sections, but here's a sentence, okay? Expanded on 1 object, 2 object, and 3 object, okay? I'm going to give you a little bit of a hint, though, and that's that this is the main connective of the sentence, right? This is a disjunction. Its left disjunct is this, its right disjunct is that. So how would you expand this case? Pause now. Okay, so I might set it up this way, all right? Let's just think about this for a second. So let's say I'm going to have something that sort of structurally looks like this, okay? So for example, this is the main connective. Therefore, the main connective of my expansion is going to be this guy. That will always be preserved, okay? The left disjunct, right, is going to be this thing, okay? And that says everything is F. Well, if I have just 1 object, that's that. And the right disjunct is something is G. So if I have only 1 object, it's going to be that thing. Okay? Make sense? So it's kind of a really interesting case here, all right? So basically what you're left with, after you sort of clean it up, is you're going to have a sentence that looks like this. And let's think about this. This says either it's the case that absolutely everything is F, or it's the case that at least one thing is G, right? Well, if there's just 1 object, that's like saying either A is F or A is G. But what's it mean if there's 2 objects? Go ahead and pause now and see if you can figure that out. All right, so once again, what we're going to do here is we're going to have our main connective, which is the OR. And the left disjunct says everything is F. So it's either everything is F, which in this case would mean FA and FB, or at least one thing is G. So either GA or GB, right? So either this holds or this holds. Well, if there's 2 objects, that means either this is the case or this is the case. Try it now with 3 objects. Okay, so once again, right, you're just going to have this, except it's going to be everything, which is going to include C, right? And so it's going to end up looking like that. Similarly, on the right-hand side, it's going to be ORs, or at least one thing is G. So it would look like this. And that would be how you expand a sentence like this with 3 objects, okay? And hopefully now you can see the pattern. You can do it for 4 or for 5, okay? All right, we're going to spill into another video, and we'll keep looking at some more sophisticated kinds of sentences, and then an argument also, where your expansions help you figure out how to show that the argument is invalid. Catch you on the next one, 5.6C.